This video will go over how to enter well construction intervals into FUDSChem. This data is typically included in a well construction diagram. Data from this diagram is also entered under the well completion information data type, which we go over in our well completion information entry tutorial video. This video is linked in the description. Go to Tools, Data Submission. Choose the correct project and event and select Well Construction Interval, WINT, as our data type. Note that you have the option to create a file or upload file. Today we will create a file. For an example of uploading data in a CSV format for a different data type, refer to our Loading Locations to FUDSChem via Flat File tutorial. This video is linked in the description. Click Create a File. Our hard copy diagram confirms that this is well CRB-MW-477S. We'll select it in the Location ID dropdown. Locations in this dropdown have already been approved in FUDSChem. If you do not see the location you need in the dropdown, uncheck the Event Loc IDs Only box. We'll start with the inner casing first, starting at the top. In our hard copy, the inner casing includes this pink cap, this white pipe known as a blank which leads down to the screen, this striped screen, and this white foot. The other colorful parts are the outer surroundings of the well, and we will enter them later. Some wells include a riser, which would stick up out of the ground, but this example does not. As a note, the system knows that risers extend out of the ground, so a riser that goes from 0 to 2 would indicate a riser that extends 2 feet out of the ground. Our example starts with this pink well cap, pictured here. When we look at the details on this well cap, we see it lists NA. This means there is no information for us to enter on the cap, so we will skip it. Next is the well casing, also known as the blank, which is shown in white. We'll go a little out of order and fill in the dropdowns according to what we find on the hard copy. We'll start by choosing blank as the classification. The dropdown tells us that blank casing is a pipe without openings below ground surface, so we know we've picked the right one. We can tell from the hard copy that it is 4 inches in diameter, so we'll enter 4 as the segment diameter. It is made out of PVC, so we'll choose PVC as the material. Note, only the first 10 items are shown in the dropdown. We can expand the dropdown to show more items by clicking at the bottom where it says items 1 through 10 out of the total number of items. Clicking here shows the next 10 items. Alternatively, we can start typing into the box to make the list jump to that letter and see items that are further down in the list. The top of the blank is not listed, so we will assume the blank starts at ground surface and use 0 as the interval beginning depth. The bottom of the blank is also not listed, but we can see the top of the well screen is at 125 feet. As a general rule, there should not be any gaps between intervals. The blank should extend all the way to 125 feet where the screen starts, to avoid having any gaps. Therefore, we will use 125 as the interval ending depth. The screen number will be 1. Sometimes a well includes multiple screens. We can see that this log has a section for upper well screen, above this bold line, and lower well screen, below the bold line. If a well has 2 screens, elements up to and including the first screen should have the screen number 1, and elements below that should have the screen number 2. For remarks, we will copy in the casing description of SCH40 PVC, leaving abbreviations. The screen slot size and % open area only apply to the screen, so we will leave these blank. Click Save. Click Add to get a fresh page for the next segment, which is the screen. Select CRB-MW-477S as the location. We already know that the screen starts at 125 feet, so we will enter that as the interval beginning depth. The bottom of the upper screen is 175 feet, so we will enter that as the interval ending depth. Update the class to SCRN for screen. The screen number is 1. We can see that the material is PVC and the diameter is 4 inches. Typically, the screen and the blank are made from the same material and are the same diameter. If the material and diameter are only listed for one, you can use the same material and diameter for the other. The screen slot size is listed as 0.02 inches. The percent open area is not included in this example. It could be requested from the manufacturer. We'll say that for this example, the manufacturer was not able to provide this information. We will use 0. For the remarks, we will enter SCH40 PVC, as well as a note that percent open area not available. Click Save. Click Add. Update the location ID. Going down, our next segment would be the lower screen. However, we can see that there is no information given for the lower screen, and it has been crossed off. Most well construction diagrams will list all possible pieces of the well, then the team fills in the parts that were actually included. In this case, a second screen was not included when this well was created, so it was crossed off. The next piece down at the very bottom is the sump, which may also be labeled as an end cap or foot. We can see that this piece was not included either, so we will not need to enter anything for it. If it was included, we would use the class of foot, regardless of whether it was named sump or end cap. Note that the deepest part of the well, in our case the screen, should match the depth entered in the well completion information table, which we go over in our well completion information entry tutorial. This video is linked in the description. Now that we've entered the inner casing intervals, we'll move on to the outer intervals, surrounding the well. This example shows a spotted white surface seal, a red grout layer, an orange upper seal, a green secondary filter pack, a blue filter pack, and a green bottom seal. Some diagrams may also include a layer of fill material at the bottom of the well. Although the concrete surface seal is pictured on the diagram, it was not installed for this well. We can see that it is crossed out. We'll go ahead and enter the next layer down, which is this red-colored grout layer. The diagram does not list the beginning depth for the grout, so we will assume it starts at ground level and use 0, like we did for the blank. The ending depth is not specified either, so we will assume that there are no gaps, and the grout extends to the top of the orange upper seal layer, and use 114.5 as the interval ending depth. The classification will be grout. The screen number is 1 because this is above the first and only screen. The material is listed as cement/bentonite. We'll find that in the drop-down. Segment diameter does not apply to the outer intervals, so we will leave it blank. Screen slot size and percent open area do not apply since this is not a screen. For remarks, we will write cement/bentonite 20-1 to match the hard copy. Click Save. Click Add. Update the location ID. Next is the orange seal. It starts at 114.5 feet for the interval beginning depth. We can see that the green secondary filter pack was not included for this well, so the seal must extend all the way down to the next interval, which is the upper filter pack. Therefore, we'll use 122.25 as the interval ending depth. The screen number is 1. Material is bentonite pellets, so we'll choose bentonite in the dropdown. Next, enter bentonite pellets 1.5 bags in the remarks. Click Save. Click Add. Update the location ID. Next is the blue filter pack. If we had 2 well screens, we would divide this interval into an upper filter pack and a lower filter pack at the bold line. However, since there is only 1 screen, we will consider this to be a single filter pack, starting at 122.25 feet and extending to 179 feet. The class is FILPK. Screen number is 1, although as a note, if there were 2 screens, the lower filter pack would use screen number 2. The material is silica sand, so we will choose SNP for sand pack. Segment diameter, slot size, and % open do not apply. For the remarks, we will enter 20/20 silica sand. The last interval would be the green bottom seal. However, we can see that the thickness for this seal is indicated as none, meaning a bottom seal was not included. Therefore, the filter pack will be the last interval. Note that for consistency, the deepest part of the material surrounding the well, typically the filter pack or fill layer, should be the same as the depth listed in the location definition table. We go over how to enter this data in our Loading Locations to FUDSChem tutorial videos. These videos are linked in the description. While we could enter information for multiple well construction diagrams into the same file, it could be simpler to give each well its own file. With that in mind, click Save and close the interface. Click Rename. We'll name this file Training Well Intervals 477S, but for your file you can give it any name that will make it easy to identify later. Next, we will click the checkbox and choose Screen to make sure there are no errors flagged by the system. If there were errors, we would be able to click on the number of errors to view an error report. We would make any necessary updates, then save and screen the file again. Since there are 0 errors, we will click Certify to send this file into the queue for review. Once you have certified the file, send an email to your review point of contact and ask them to review and approve the file. Depending on your district, this may be someone at the Corps or someone at Synectics. The person who is reviewing the file will follow the process outlined in our Well Construction Interval review video. This video is linked in the description. Don't forget to subscribe to the FUDSChem YouTube channel for more tutorial videos. All of the tutorials and playlists mentioned during this video are linked in the description below. Lastly, if you have questions or comments, feel free to contact us at fuds.support@synectics.net. Thank you.